Today we are going to be looking at simple alternating current circuits 2. This is the second or the continuation of the first part of this topic, and previously we had considered the following: definition of AC circuits, solve problems on root mean square current and voltage, solve problems on AC circuits, although it was specifically on capacitive reactance. So today's class shall be basically on inductive reactance. The revision for the expression we used initially, you can see here equation 4. We are not starting from equation 1 because it is just a continuation. So this was equation 4 in our previous class. You see the root mean square value of current is equal to peak value of current all over root 2. So if I divide 1 by root 2, then I will obtain 0.7071. We use the same number for both equations because they are the same. Both expressions are the same. When you divide 1 over root 2, in the first one, as you have seen, I naught over root 2. When you divide 1 over root 2, you will obtain 0.7071. So if you don't use the first one, then you can use the second one. Both of them are basically the same. For current, the same expression, but this one is for potential difference. Here we have peak voltage, peak root mean square voltage, and peak voltage V0, and then the root mean square voltage VRMS. So VRMS equals to V0 all over root 2, or we can as well write it this way: capacitive reactance XC. We had discussed about this, the opposition to the flow of alternating current as offered by a capacitor. So you'll see here the SI unit is in ohms, while the unit of capacitance is in farad. This is the mathematical expression XC for capacitive reactance in equation 7. XC equals to 1 over 2 pi FC. So F is the frequency, pi is a constant, and C is the value of the capacitance in farad. So you see that the capacitive reactance is the inverse. Here we have 1 over 2 pi FC. Unit is in ohms. Applying voltage of frequency to the capacitance C, we obtain V equals to IXC. Look at equation 7. The unit is in ohms. This expression is gotten from Ohm's law, V equals to IR. But in this case, we are not using a resistor, so that place is being replaced with the value we would obtain for capacitive reactance XC. Inductive reactance XL. And we made mention that inductive reactance is the opposition to the flow of alternating current as offered by an inductor. And the SI unit is in ohms, and the unit of inductance is in Henry. Unit of inductance L is in Henry, which is capital H. So equation 9 gives the mathematical expression for inductive reactance XL equals 2 pi FL. Equation 9 and equation 7, can you tell the differences? For XC, it's a ratio, and we use the value for capacitance, and XL is not a ratio, and we use the value of Henry. the value of the inductor. Applying voltage or frequency to the inductance, not capacitance, inductance L. Please note this place. This is inductance L, not capacitance. Okay, so we obtain V equals to IXL. Okay. Example 1. A 2 microhenry inductor is connected directly across a 150 volt root mean square and 60 Hz AC source. Find, the first one is the root mean square value of current, and the second one is the peak value of current. No matter how sound you are in physics, you must first of all list the quantities given. So from the quantities given, you would be able to estimate which expression is suitable for you to use in solving the problem. So looking at the first one, we have an inductor, 2 microhenry. Remember, the micro there could be written in index form as 10 to the power minus 6. So in case you see something like that, you should not be confused. What quantity do we have according to the equation? Root mean square voltage, 150 volts. Look at the next one here, 60 Hz. That's frequency. So I used to say that the SI unit tells us what the quantity is. Also look at the unit, it will help you. Pi has been given, so take pi to be 3.142. There are times they may consider pi to be 22/7. It depends on the nature of the equation. But here we are using 3.142. Okay, so for us to find the root mean square value of current, then we have to use the expression here. V root mean square equals to I root mean square times the inductive reactance XL, and we then make the root mean square current the subject. When we make the root mean square current the subject, we are going to now have consider the value of voltage, root mean square voltage, and the value of the inductance as well. Okay, so let's see. This is the expression XL equals to 2 pi FL. Because looking at this expression, V equals to IR, we have the V is given, but we are to solve for XL. I hope you can see that they gave us the value for the inductance. So we are to find the reactance XL. Now, that's the first thing we are going to do. XL equals to 2 pi FL. 2 times pi times 60, the value of the frequency, times 2 times 10 to the power minus 6. Remember, I told you that this symbol here, you are seeing here, look at my arrow. This symbol you are seeing here is for the value 10 to the power minus 6. So you don't ignore it except it is not there. We now introduce that value here, 10 to the power minus 6. So when we simplify it, we get our solution 0.00075 units in ohms. So we can now go ahead and make I the subject from this expression that we considered here. Let me point this. So this expression you're seeing here, I brought it here. We're going to make I the subject. When we make I the subject, then we have the value in ampere, the unit of current. I believe you have seen how we got this value here. In place of root mean square voltage, where is the root mean square voltage? Look at it here. We substituted this value, and in place of inductive, this is XL, not XC. This is XL. Okay. We now use the value here. Is that okay? Then using the value for the peak current, then we make I naught the subject from equation 4. We make I naught the subject, then we'll get this. When we substitute the value for the root mean square current into this expression, look at the value for root mean square current here. We'll now substitute into this expression. You can as well do that, and then you tell me what the expression will be. Okay, so that's our answer for this very example. Let's look at the second example. We have an inductive reactance being connected across a 0.2 Henry inductor when AC voltage of 60 Hz is applied across it. If the voltage is given by V equals to 150 sine 120 pi t, calculate the root mean square and peak values of the current. Calculate the root mean square and peak values of the current. So you have to consider the quantities being given, and then the next thing is for you to now consider the units, the symbols which we are going to use. Let's proceed. 0.2 Henry is given. Frequency 60 Hz. Then potential difference V equals is also given. So you see clearly this is the expression in our first class. I think this was equation, though I can't remember the number, but this expression, we use it to make comparison with what is being given here. So when we do that, we cancel out the common terms. Like if I strike this, I strike all this, with this expression, I can as well deduce the frequency from here, like we did in our first class. So if you've not watched that tutorial, I would like you to go and watch it. From here, assuming the frequency here was not given, I would have been able to deduce the frequency from here using this comparison, the method of comparison. This and this is also compared, so you see that V0 here is 150, so I've been able to see the value of my peak voltage. So peak voltage, when we compared, we had V0 equals to 150 volts, so it's written there, is given. To calculate the root mean square current, we need the expression I root mean square equals to V root mean square all over XL. I root mean square equals to V root mean square all over XL. So look at this. Do we have root mean square voltage? Also look at XL. Do we have it? Anything we don't have, we have to solve for it. Then by substitution, we derive the unknown. Okay, so we use the expression so we can obtain the root mean square voltage. V root mean square equals to 0.7071 V0. Remember, I told you it's the same as the other expression. So we are going to substitute the value of V0 into this expression. I hope you've seen what's our V0. Look at it here. Bring this here. So in place of this, we are going to put 150. That's our answer. So we have been able to solve for the root mean square voltage, this one. It is left for us to solve for the XL as well. You can start solving for XL, so you compare your value if it would be the same as what we have here. To obtain XL, we use the expression 2 pi FL. So XL equals to 2 pi times 60, the value of the frequency, times 0.2 Henry. And so you see that the substitution is in order. Let's go ahead. Our reactance is 75.40 ohms. So for us to get the root mean square current, we are going to substitute the value for XL and the root mean square voltage. Using this expression, we have done that. So this is our value of current. But we are not going to stop here because we were instructed to calculate root mean square and the peak value of current. So we are also going to find peak value of current. This is the expression we are to use. When we do that, we obtain I equals to 1.99 ampere. Okay. Thank you for watching Supreme Online Lectures. Please subscribe to our channel, like and share. Have a wonderful day.